Great, good afternoon. I'm Stephen Bowers. I'm going to teach you about Suture Shield, a device that I invented to manage the needles in robotic operations. Why robotic surgery? Minimally invasive surgery is hard. I've done this for almost 30 years. It has obvious clinical and health benefits. It's hard to get to do, it's hard to do. Robotic surgery makes surgeons better by improving suturing dexterity, improving ergonomics, particularly in the pelvis and where it's hard to reach, negating the impact of a thickened abdominal wall on the surgeon control of instruments. Okay? So when two of these factors are present, suturing, pelvic surgery, obesity, it is a surety that robotic surgery will dominate the market. Think prostates, think bariatric surgery. Young surgeons are all in on robotics. The surgeon workforce is being replaced at about 3% per year. Older non-robot surgeons out, young robot surgeons in. In addition, Intuitive has been certifying existing surgeons at a rate of about 4.5% of the workforce a year. So the surgery workforce will soon be the majority robotics and will eventually be entirely robotic surgeons. There's forecasted growth of 15% a year over the next 5 years, ultimately culminating in a $40 billion global enterprise. There are multiple new platforms entering the market. What's the problem? Okay, so a critical safety feature of all robotic platforms is that the robotic instruments must be open on entry and withdrawal from the abdomen so that a tech doesn't remove something when it's holding on the colon. Everyone understands that. So there's an inefficiency in getting needles that are necessary for reconstruction into and out of the body. Okay? The public would be astonished or maybe even horrified to know of the lack of sophistication of the status quo. These three methods are used, what you see here. On the left, the surgeon just operates one-handed for a while that existing port is used to put a needle in. He has to wait for that robotic arm to reboot. It takes about 1.5 minutes per needle exchange. Second, the surgeon takes all of his desired needles for the entire operation, sticks them in the abdomen, and plugs them into organs of opportunity everywhere in the abdomen. Thirdly, the surgeon has a paid assistant on the right sitting amongst the robot arms, passing needles between the robot arms. Where in any industry, when you add a robot, does it increase the number of personnel required to do a task? Only robotic surgery, only. In addition, there's anxiety and potential safety with all these techniques, and we measured 3% of operations at Mayo Clinic that have a non-retrieved needle that the team has to spend about 35 minutes looking for, okay? And we presented it at a national meeting. So I invented the Suture Shield, whereby this simple device, the surgeon takes all of his intended needles, loads it on the device, places it into the abdominal cavity himself or herself before docking the robot, then places it on a tissue of opportunity, then goes to the robotic console, uses the needles, replaces them back on the device, and then using the needles, going to replace them back on the device once used. The needles are all immediately visible and countable throughout the entire procedure. Then the device is extracted after the robot is removed, making sure that all needles are always accounted for at all time. So I have used a clinical prototype of this device in over 200 patients. For all of my bariatric surgery, all of my inguinal hernia operations, I make one out of existing FDA-approved materials. Because I've been able to do that, I've been able to refine the design, but also I've given actual real value to our unit. We had to hire one less PA, saving us about $150,000 a year. I went through Mayo Clinic Ventures. I patented this device. We had our patent issued this year, so now we're up and running as a company. We have, the Suture Shield device was designed to allow surgeon point-of-care decision-making on needles used, to allow the largest commonly used needle in the smallest commonly used trocar, to allow this to sit with stability on tissue, and to have all needles accounted for all the time at a palatable cost. You can see in the disciplines that use robotic surgery that general surgery is where the weight of opportunity and growth is. Okay? So that's what we're targeting. I'm going to do a deep dive into the bottom line inguinal hernia because it's the only operation that has no outside medical innovation that could influence the annual progression or increase in utilization of the device in this market. We know that 1 out of 4 people in this room have had or will have an inguinal hernia operation in their lifetime. We know because of aging population, the inguinal hernia rate is increasing at 5% per year. We know that robotic utilization in inguinal hernia has been going up about 15% per year and will continue to go up because of, again, new surgeons are doing this. This is done by all surgeons in the market. A quick look at, in blue, our growth metrics, which are very reasonable, we think, indicates that pretty soon we will have a very, very high value product in this operation alone, which is about 20% of robotic utilization. This is our lean and fractional team. Bill is a serial entrepreneur. Kirk has a background in corporate product development and has deep ties in Asia, which is the second highest growth market for robotic surgery. We are raising funds by a convertible note. We're about just over halfway to our fundraising goal, and we have the standard rates. Where we are right now is we're at design freeze. We are in the V&V process. We are funded sufficiently to get to FDA clearance by the end of this year. And then next year, we're going to have our early clinical release. I've already identified the sites. I run the Surgical Supply and Technology Transfer Committee at Mayo. I know we're going to be in Mayo Enterprise. We're starting to look at non-dilutable capital sources, corporate loans, STTR grants, and at angel groups. And then we'll engage with strategics once we have some early clinical data. We've been very lean and very attentive to our capital expenditure, and we think that with the upside that we have to have an FDA-approved device at this level of spend is remarkable. This is our device. I'll let you see it, hold it. This is what we need going forward in 2026. We need to manage a sales force. We need to get a little bit better scale to reduce our cost of goods. We need to exhibit at surgery conferences and have some clinical advisory meetings. This is what we're asking for, is to get to around 800,000. So in short, we have a very simple device that meets a clinically unmet need in a massive global market that is a high-margin, single-use device developed at the most trusted brand for healthcare in America. And we'll make it in America, and we will never be on back order. And please, I'm happy to answer any questions. Thank you.
I have a question. Have you started the STTR grant process yet?
So I submitted our micro grant to MCRI, which, and that they offer that service to Mayo, so there's a little bit of a competition, but I've also started working on the actual grant in case we don't get the micro grant. That's submitted. The next submission is January 2026, and we're thinking that this obviously has NASA and DoD capabilities. So thank you, Gregory.
Yeah, I'd like to talk to you more about that.
Yeah, perfect. Thank you.
So first of all, my belly button looks great, so thank you for that.
It's great.
Because he operated on my belly button hernia. All right, I'm one of those stats there. It was robotic, so it was wonderful. So my wife thanks you too, by the way. So talk a little bit about your go-to-market strategy. How do you get this out there? I know you can get it into Mayo, but what's the plan, right? I saw $130,000 for a salesperson. But what's the plan to really get this out there?
So we want to stay lean. So our plan is there's a very active Facebook robotic surgery collaborative. It has 16,000 members. It's really checked pretty often. There are some very influential people on there. We've contacted those influential surgeons who are good. There's some influential surgeons who are not good, but influential surgeons who do a good job with things, are academically minded, and have work in progress on getting them to be initial users and on the clinical advisory board. So we believe that once this is out there, people will want it. But we're also going to exhibit at the 4 major surgery conferences that are most well attended. SAGES, the American Hernia Society, the American Society for Metabolic Surgery, and the American College of Surgeons Congress.
So is this reusable?
Single use.
Single use.
Single-use disposable, injection molded silicone. We can 3D print it until we get enough, until we make our molds. Molds are expensive to do injection molding at a high level. So that's our plan, is to some point in this next year, once we're funded sufficiently, make molds, and then we can get our costs down to made, sterilized, wrapped cartons for $8 per.
So you can 3D print what you have there?
It's 3D printed.
That's 3D printed?
3D printed silicone.
Okay, very cool.
It has all the handling characteristics. It's the exact same material that we'll injection mold it out of. Same durometer setting, same everything. And that's why it takes some R&D to come up with the right flexibility, thickness, that kind of things.
So that was my question. I mean, is this just a rounding error in terms of the cost to surgeons like yourself to incorporate this? Because it's got to be, I mean, the robotic equipment that they use and all of that, I'm sure, is outside of the scope of your business. So tell me a little bit about, like the cost of goods. How does this scale? Let's say, you grow this company 10x what you think you can do next year. What does that look like? What does the margin percentage look like?
So I mean, the standard in medical equipment is a 75 to 80% gross margin. So we are priced to achieve that with the CAPTIS discount. So like Mayo Clinic is involved in a CAPTIS collaborative that tries to reduce the cost of all supplies. So we're pricing it so that with that discount, we can still meet our 75 to 80% gross margin. And so, and we think that $70 per is a palatable cost for everything. So that's what we're going to initially charge, knowing that if we price it higher, some people will say, I don't really want that. But I think at that level, pretty much everyone's going to say that's a negligible cost. Open it. Sir. Phil.
No, you kind of answered my question there. I was just curious on the cost structure as well. Just in terms of volume, can you give me a sense of how many of these would go into a hospital like Mayo Clinic? Like how many would you need per year?
Yeah, so we're doing, wanted to say somewhere around 1,100 robot operations a month, something like that. So I think that's something like once you get it in a hospital, you're going to generate revenue.
I'm just curious, how do you get a code then? Because I'm sure the hospital's going to charge, if they're paying 70, they're charging 300 for it, right?
I don't know that. I don't know.
We should have asked the administrator.
They certainly may. I mean, if you have contract insurance, you're going to get upcharged for something. So I don't know what that would be.
Okay.
That's not the purview of the committee that I'm on. So
Yeah,
thank you.
Got it.
Well, thank you very much. It's a great opportunity. Look forward to meeting you guys.